This is a production of Cornell University.
Hi, everyone. Welcome to the 2023 Hemp webinar series. Actually the last webinar of this series. Once again, my name is Luis Monserrate, your host. I'm a second-year PhD student in plant breeding and genetics in the Lair Smarts Lab at Cornell University. And I'm accompanied by Tom Baracco and Kim, who have helped me put this webinar together. And lastly, I just want to mention that this webinar series is a component of a larger project, which is the development of 8 educational modules that will be freely available on the Cornell Hemp website at the end of this series, which is today. But I'm hoping to have everything up and running by the end of the month. Each module will have the recorded webinar, an instructional slide deck, and a set of high-impact papers pertaining to the respective subject. This paper will be provided by the speaker of the module. Also, at the end of the, all the webinars will be recorded and will be available on the Cornell SIPS YouTube channel. So if you or anyone you know missed any of the sessions, please feel free to access our YouTube channel and look at the playlist of the 2023 Hemp webinar series. So with that, it is my pleasure to introduce the presenter of today's session or seminar, Jamila La Malfa-Donaldson. She's an industrial hemp PhD researcher with experience in testing, processing, and cultivation of industrial hemp, who just finished her PhD at Aberystwyth University. Did I pronounce that right? And her talk today is going to be on processing, extraction, and testing. So without further ado, please, Dr. La Malfa-Donaldson, take it away.
Hello, everyone. Thank you so much for joining us all today as I do my best to give a presentation about what I've learned so far around hemp processing, extraction, and testing during my PhD project, which I'm almost done with just in the final few months. My work has been based at Aberystwyth University in the UK. And I want to take the opportunity now to thank Louise, Tony, and Kim for inviting me to join Cornell University's Hemp webinar series this year. So be sure to check out the other presentations. In this webinar today, I will be introducing industrial hemp within a UK context, as it gives some idea as to what how my research fits into what's going on here at the moment. Then I'll be introducing, just outlining hemp processing and some of the methods involved. So some of the work I've been doing is around developing a testing method for cannabinoid potency. So I'll be outlining that. And then we'll be discussing some of the extraction techniques that are widely researched and published. And then we'll discuss some of the key kind of scientific concepts that are important to understand in developing processing methods for hemp, including solubility and decarboxylation. And then I will go on to discuss one of the purification techniques that some of my research has involved method development around, which is crystallization. So we'll be introducing crystallization, some of the solubility curves that I've been able to produce, and just a little bit more insight into the work I've done with hemp distillate and scaling up, a small kind of step up in scaling up the method. I welcome any questions at the end. So just to introduce hemp in the UK, as there may be some similarities, also differences to other parts of the world, including the US. So industrial hemp here are considered varieties, cultivars of cannabis sativa, which are typically grown at large scale as an industrial crop outdoors, and it can be legally grown here in the UK with a license. The cultivars that can be grown are from an EU-approved list of cultivars that have been bred for European conditions. And they are, and they are often sourced from Europe, and used by growers here in the UK. At the moment, the hectares of hemp being grown across the UK is increasing as demand and interest for hemp products also rises. One of the limitations of current hemp regulations in the UK is that the growers can only limit their cultivation of hemp to the stalk, which is a source of fiber and other materials, and the seeds, which are also used for several industries. And so the flowers and the leaves of the hemp plant are considered waste material. And so my project sought out to better understand the value in this quote unquote waste stream as a means to obtain some valuable end products. And in the case of hemp or cannabis, the leaves and the flowers are where these therapeutic compounds accumulate, mainly cannabinoids. Hemp is characteristic when considering its chemical composition, as it typically yields higher amounts of CBDA, which is the acid form of the compound cannabidiol or CBD. And so the processing of hemp involves methods and techniques which are looking to extract and obtain this valuable compound, CBDA, and convert it into CBD. So I've been very fortunate enough. My PhD project was the first at Aberystwyth University to involve working with hemp, which has been an incredible and privileged opportunity. But it also means that we've had to really build a lot of the research methods and workflows from the ground up. And so the picture of the hemp in the field here was when we first sowed hemp seeds in 2020. And we had kind of preliminary trials of a few varieties, a few cultivars. And since then, we've grown year on year, adding different cultivars and collecting not only cannabinoid data, but also seed and stem yields. So as I mentioned, hemp processing is all about extracting these valuable and therapeutic compounds. What one consideration needs to be is the initial chemical composition of the material that you're extracting from. In the case of hemp processing, it can really range, and you may be able to have very kind of cannabinoid or trichome-rich plant material that has been carefully cultivated for highest yields. Or you may have a lot of hemp waste and residues left over from processing hemp for seed, or rather fiber. And so your plant material is not going to just contain cannabinoids, it's going to contain other different components as well, as shown in the diagram at the top. And the hemp processing method involves extracting as much as possible from the plant materials of what you want, and then further purifying that extract to get rid of what you don't want. And then in depending on what products you make, and in this case, this project was focused on creating cannabinoid isolates, you then need to further isolate that extract to get your final single compound. And like I mentioned, this case is CBD. And I would argue that testing is very, very important, not only for quality assurance and control, but for optimizing methods throughout the processing step, throughout each processing step. And so hemp testing can involve looking at many different compounds. And my work has been around developing the chemical profiling method for cannabinoids and flavonoids that our lab now can use for other research projects involving hemp. So to develop a cannabinoid testing method, you need to consider what you want to look at. In this case, it was a method developed just for cannabinoids And so liquid chromatography, which is a process which involves separating out all of the compounds that you're looking for into distinct peaks that you can then use to quantify and find out how much of each of these compounds are in your sample. LC is widely used and suited for cannabinoids, as opposed to gas chromatography, which involves heating the sample, which can lead to degradation of some of the compounds into other forms, which we'll talk about in a moment, and which can impact your final results. I've also used in tandem with mass spectrometry, which has been a means to further distinguish and identify cannabinoids which coalute, which means they don't separate out as well and they form one bigger peak. And so as seen as on the screen, I was able to use these methods to look to identify not only the major cannabinoids of interest, so the CBDA and CBD that I've mentioned, but also some other quote unquote minor cannabinoids, which are increasingly showing some therapeutic potential, like CBN or CBDV, as well as canaflavin A, which is a unique flavonoid to cannabis. And so a lot of testing methods up until now that have been published have been very much focused on just the potency, so just THC or just CBD in samples, which have typically been developed, methods that have been developed for kind of drug enforcement. Whereas I endeavored to put together a method that we could use in our lab to analyze a wide range of different components, as again, each of them are being, showing more therapeutic potential. A lot of work I've done as well is also a consideration of how many samples we wanted to get through. So research projects often sample a lot of plant material that needs to be analyzed. And so we needed a sample preparation method ready to get the samples ready for analysis in the LCMS as quickly as, in the shortest time possible in the simplest way as possible. So I was able to develop a method using very small amounts of plant material. Again, when you're developing research methods, you have to consider how much plant material you can obtain from the plant without, if you're for example, a lot of the work we did was sampling cannabinoid content over time. So we wanted to leave the plant intact and be able to not affect too much its growth, but also obtain enough sample for us to be able to process in triplicates to get accurate cannabinoid profiling. So the method that I developed involved the use of methanol as an extraction solvent. So we did some work looking at different concentrations of methanol. We did compare with ethanol and finding my results anyway showed slightly favorable yields in methanol, although ethanol is another great extraction solvent to use. I also looked at the number of times the extractions were repeated, often finding obviously having data to show that the cannabinoid content, the majority of the content was yielded in the first extract, and then once that solvent was decanted and removed and fresh methanol added, there's a little bit more cannabinoids in the second extraction and little to none in the third. So looking at different repeat extractions as well, as looking at solid phase extraction techniques to further clean up the sample to ensure that nothing else in the plant sample would irreversibly bind to the C18 column that was used in the LCMS. And then, of course, a lot of work around the different, the gradient being used in order to separate out the compounds as much as possible to get clear and distinct peaks, as it seems on the screen, in the shortest amount of time possible. So there's a lot of considerations, things that need to be tested in order to develop a method for testing, but crucially important for processing, as I would argue need to test as much as possible every stage in order to best optimize the extraction process. So the final method was able to detect 11 cannabinoids and canaflavin A in 25 minutes. So this is a really neat diagram that I found in a paper, giving a really nice overview of the extraction techniques that are used for hemp. Whilst it's not containing all of them, these are the ones that are most widely used in academic research for hemp. I will note that here it makes mention of techniques that can be used for extracting fatty acids and other compounds from the seeds, as well as other plant material which contain cannabinoids and other chemical constituents. So we'll skip the first one, but one of the most common extraction techniques is dynamic maceration, which basically means immersing your plant material in a solvent, typically an organic solvent. And then we have pressurized liquid extraction, which uses pressure to improve the extraction efficiency. Then supercritical fluid extraction, typically with CO2 as a quote-unquote solvent, which uses changes in temperature and pressure to shift the solubility of CO2 and enable it to flow over the plant material and extract different compounds. These are all methods with different pros and cons, not only for yields and selectivity in terms of what exactly you want to take from your extracts from your plant material, but also for cost and other running costs and capital costs that you may need to consider. So there's no one size fits all for any processor. There needs to be a consideration of what the potential is and what you're trying to achieve. Some other more newer and novel extraction methods are also being explored, such as ultrasonic assisted extraction, which uses ultrasonic kind of waves to help mix up the plant material and break down the cell walls in order to get the therapeutic compounds. And similarly, microwave assisted extraction, both more new and novel techniques, but are still being found in the literature as potentially more, different selectivity and for hemp extraction. So what we're finding in the literature is it's really a challenge to look at different studies and compare them like for like. There are sometimes some limitations due to the reporting. There may not be, a lot of studies don't necessarily report the starting composition of the material and thus the recovery. So they will show a change, they'll show a yield, it will show an amount they've been able to extract from the starter material. But understanding the initial sample and the material that was used is really important, not just the chemical composition, but the moisture content, how it was stored, in what conditions, and what temperature, etc. So it can be really hard to make that comparison. I mean, some pieces of kit are not exactly the same. There are also techniques that are utilized, you must consider, at lab bench scale all the way up to pilot industrial scale. And so the yields and the efficiencies will change with that. So it's when you're looking at studies, it's really important to consider the reporting and what information is actually being shared when considering and contrasting different extraction techniques. So I wouldn't say that research at the moment said that this is the one best extraction technique to use. It is a bit of a dark art, and but ultimately requires a lot of testing and scientific rigor and statistical methods to work out what is best for you and your system. So an important consideration, however, when selecting a extraction method, particularly around using solvents, is the solubility of cannabinoids. On the screen are a list of some of the most common organic solvents that are used to extract cannabinoids with. You'll notice that there's listed the polarity. However, polarity should be more understood as a scale. And so we have solvents that are more polar and less polar. The more polar solvents, although cannabinoids are cannabinoid extraction favors more non-polar solvents, which are more suited to the cannabinoids and their chemical structure. Quote unquote more polar solvents such as ethanol, methanol have a kind of a wider polarity and are able to extract a wider range of compounds from extracts given their OH alcohol group. It's also important to consider the boiling point of your solvents, as once you have contacted your solvent with the plant material, you then need to use means, typically heat, to remove that solvent as well. And residual solvent is something that should be carefully monitored when producing hemp products. I mentioned earlier the use of supercritical fluid extraction using CO2. So CO2 is a gas. However, by manipulating the pressure and temperature, you can take it up to its beyond its supercritical point in order to change its solubility. And this gives you a lot more selectivity as you're able to manipulate these processing conditions and thus the solubility to get to target specific chemical constituents and compounds. You'll often find in the literature that you can also use a cold solvent such as methanol in supercritical CO2 extraction to aid with the extraction as well. Another type of solvent group that is being increasingly featured in research is deep eutectic solvents, which are ionic solvents, that can be a mix from different organic matter, and they're often quoted as being green and non-toxic, like some of the other aforementioned solvents. And so it's interesting to see, however, what some of the yields are for all these different kinds of solvents. And in the case of the deep eutectic solvents, there may be some challenges in removing those solvents as well. So there's still a lot that can and should be explored. Into having this solubility data is really important for your specific to your extraction system. Another really important consideration for hemp processing that may not be a feature or consideration for other bioactive compounds and other plant material is the decarboxylation process. Very simplified diagram showing the CBGA compound, which accumulates during plant growth, which then a enzyme or a synthase can convert into CBDA and THCA, and then a decarboxylation reaction, which involves the removal of a CO2 group, the acid group, it forms the neutral states of the cannabinoids. And this process is largely driven by light and heat, and also occurs over time. And so it's really important to consider if you are using heat in your process, what is going to happen to the compounds in your material, and how you can manipulate faster, high temperature, high and low temperature to control the decarboxylation reactions for specific cannabinoids. So there's many other steps in the processing system kind of method. Winterization is typically used to remove fats or lipids and waxes. It involves, again, immersing your extract in a solvent and freezing in order to solidify those constituents and then remove them. and then other solvent removal methods and distillation. But I thought I'd skip to some of the work that I've been doing around purification. And this is to attempt to isolate a single component, in this case, CBD, for a final product. I've been fortunate to have the opportunity to use a Crystal 16 machine from Technobis, who provides crystallization systems, and it's incredibly easy and helpful to use. It involves 4 different reactors with 4 slots, and each reactor you can set up very easily using their software a temperature ramp to change the temperature and the rate of cooling. And there's also, so I would prepare samples using in this photo CBD isolate to start off with for the method development, and in various solvents, and using a small magnetic stirring bar at the bottom to agitate the mixture in order to create crystals. But how does crystallization work? So what happens is you create a solution which is saturated with what you want to crash, what you want. So in this case, it was CBD. And when you increase the temperature, the concentration of the CBD in the solution goes up as it solubilizes within it. And then as you drop the temperature, the solubility, the concentration in the solution drops as well, as the components of the CBD is no longer soluble in your solution at lower temperatures. And so this enabled this work enabled to do some method development around that temperature ramp and the concentration of CBD that you need to start to generate these crystals, and how you then and that would then inform other crystallization steps. So on the right, we have a generic CBD solubility curve, again showing this change in CBD concentration in the solution as temperature decreases and the CBD crashes out of the solution. Intentionally, with the intention of leaving behind other components and possibly other cannabinoids. So here is a solubility curve that's been generated by the Crystal 16 machine. So I looked at 4 different solvents. The green is the pentane, the blue is the hexane, the red is the heptane, and the black, I believe, is octane. And this is showing that for the concentration that of CBD isolate that I'd used, we're getting different solubility curves for each of the solvents that is matching the chain of the hydrocarbon chain of those solvents. So hence having 5 and octane having 8. And right here on the right, able to see a small vial. So it just uses, this machine uses HPLC vials and is able to crystallize a small amount and successfully using these different solvent systems. So then what I was able to then do was use this information to use the same machine to crystallize hemp distillate instead of CBD isolate. So the isolate would have had above 99% purity, so about 99% content of CBD, whereas the distillate had 79% CBD. And for each of the solvents, I was able to develop systems which were able to crystallize the CBD out of the hemp distillate to create purity of 90% and above. Interestingly, the octane with the longer hydrocarbon change yielded the biggest percentage change. However, there's also certain considerations that are needed for crystallization methods, including the boiling point of your solvents, because it's really important to be able to remove the solvent as quickly as possible before the crystals go above, go to a temperature high enough so it solubilizes back in. So in my case, I was able to, in my methods, I was able to get the hemp distillate and solution in the solvent solution down to 0 degrees Celsius, which, correct me if I'm wrong, I believe that's 32 Fahrenheit. And then you typically harvest those crystals at freezing, wash them with hexane to get rid of any other impurities, and then you'd have your final crystals, and with as much solvent removed as quickly as possible. So pentane is typically a solvent used for crystallization systems. And so now I've been taking this work a step further. Just recently, I've been looking at a kind of slight scale up using a jacketed reactor. You've got it on a heated stirring plate. So I've got a magnetic stirrer inside and a temperature probe coming out the top. And then the pink is actually the glycol from the chiller. And so I was able to weigh out the hemp distillate and add a solvent. In this case, it was octane. I gave octane a go the other day, and I was able to, because I knew the temperature to start out and then ramp down to freezing, I was able to get a batch of crystals, and in the process of preparing for analysis to determine the purity. So yeah, this has been quite interesting and nice work. So just to summarize, we're interested in industrial hemp now as a source of therapeutic compounds, in addition to its kind of uses for seed and its stalk. But there needs to be more research and work done to develop and optimize processing methods specifically for hemp, which hemp and its materials with all its different chemical constituents. LC liquid chromatography is a widely used method for cannabinoid profiling, and other testing methods can be developed with it. We've also kind of introduced some existing and novel extraction techniques. There not being a definitive kind of best one, but it depends on your processing objectives. Non-polar solvents are better suited for cannabinoids, but some of the safety issues mean that they have fallen out of favor, and so other more polar, let's say, solvents are being used, such as ethanol. Just discuss the decarboxylation of acid cannabinoids to neutral cannabinoids, which is an important reaction step in your processing method, and one to consider for your selection of your extraction method. And I've just kind of outlined some of the work I've been doing to develop crystallization methods to purify hemp distillate to isolate CBD. Just a little bit about me just before I go. So I'm based here in the UK. I have a background in chemical engineering business and have experience communicating science in schools. I've also recently founded my company, Purification, and won several awards, including Young Innovators Award. I've learned so much, and it's really been an honor and privilege to be able to work with cannabis, especially in a country where it's only only recently been medically legalized. And I'm always keen to connect and learn as much as I can from others. So do check me out on LinkedIn, and feel free to email me anytime. Thank you so much for this opportunity, and I apologize for the interruptions. Thank you again.
Thank you, Jamila. It was a great presentation. And I can see that you have several questions.
Okay, thank you so much for your questions. I'll start from the top. Aaron asks, where were the samples over time taken from the plants? Where were the samples over time taken from the plants. Okay, so I'm presuming that's the parts of the plants you're asking about. Do you ask again if I've gotten this wrong? So from the field, the leaves were sampled at 3 points along the plant, so kind of bottom, mid, and top. We also tried sampling just the outermost, the most mature leaves, most extended mature leaves towards the top. And then we've also taken the flowering tops as well and sampled those. Yeah, I have done a bit of work around some analyzing leaves sampled that I've taken up along the plant, and do find a lot of variability, although in the literature it does show that cannabinoid content does decrease as you go down along the plant, but their plants are not homogeneous, and so yeah, considering where you do sample from on the plants is really important. But do ask again if I've not got that quite right. Pressurized liquid extraction is wouldn't be considered the same as a heat press, just given you're not using the liquid. But yeah, that's just more mechanical, thermomechanical means of extracting. But that I would say is more suited for cannabinoid rich plant material that you wouldn't necessarily find in hemp grown here. Well, it can be, but we're waiting to hopefully get access to a wider range of cultivars with higher cannabinoid contents than the ones we have at the moment. Thank you for your question, Fred. Peter, do any solvents used during extraction carry a risk of reacting with the desired extracts? Do any solvents used during extraction carry a risk of reacting with the desired extracts? I wouldn't say that there were any particular reactions, the risk being, however, the insufficient removal of that solvent, which would be a problem for your extract. But thank you. Vahid, thank you for this informative presentation. You're most welcome. I am not an expert in extraction techniques. I don't think anyone is, but keen to know whether increased nitrogen fertilizer rates affects cannabinoids. If yes, how? Yeah, very interesting question around nitrogen fertilizer. I was not involved in this work, but there was a very small nitrogen trial done with the hemp grown here on campus. If you want to email me, I'm sure we can find some more research that's already been published on this topic. But the hypothesis is yes, that increased nitrogen fertilization would increase cannabinoid content. What I think the nuance is at what point of the growth stage that you add that fertilizer and how much. So that's where the work needs to be done, and maybe you can research that. Thank you. Michael, is hemp CBD safe to use after that process? So it depends. It depends what part of the process. So we had extraction, purification, isolation, and at whichever point you kind of get a product out of, each of those steps will determine kind of the final product. And so right at the end, you're going to get an isolated CBD, and I wonder if that's what you're referring to. The safety of CBD isolate has been very much up for discussion. I would say the literature points to CBD isolate being safe to consume in the right amounts. However, a lot of the literature now is demonstrating the efficacy of a kind of chemically rich and comprehensive extract which I guess people refer to as being full spectrum. And this is why I endeavored to make sure that our analytical work would be able to capture as many of these cannabinoids as possible, which together can have a potentially greater efficacy than CBD isolate on its own. I would argue that this effect, known as the entourage or the ensemble effect, requires a lot more research, which is very exciting. But yeah, I would say definitely do your research. If you have any questions, do reach out. Fred, what temperature have you found to be best for decarboxylation of hemp? We've been using 240 Fahrenheit, whereas with THC cannabis, we use 225 Fahrenheit. Do you agree, concur that CBD and CBG use a hotter temperature to decarboxylate than THC flower? Thank you. Okay, so I fortunately have not done any personal work around decarboxylation. However, if my memory recalls, there has been a study looking at these kind of general approach to decarboxylation, and I think it's really interesting, your results. I think it was the hotter temperature paired with a faster reaction time that was more selected towards THC, but I'll confine the paper and send it to you. I'm afraid I just don't have it at the top of my mind at the end of this day. But yeah, do get in touch, Fred. I'd love to know what kind of work you're doing. Daniel, could you please tell us a little bit more about your startup, Purification? Thanks. Thanks for your interest, Daniel. Yeah, my Purification I started last year after winning a kind of dragon, Shark Tank, that's the newest version, Shark Tank kind of style competition here at the university, and I've since then received a lot of support, and I've been developing plant-based foods from hemp seeds, and partnering with the Innovation Centre here. So yeah, this has been during the final year of my PhD, so it's had to take I've done what I can, and I've gotten started with a few products, but I'm keen to do more, and yeah, would love to speak to anyone about it more, so do get in touch and stay connected over LinkedIn. Thank you for your patience. Wow, there's quite a few. Okay, great. Are we good for time? Perfect. Sam. Hi, Sam. I have heard parenthetically that the roots of the hemp plant contain similar therapeutic compounds. Did you see see any reports on the root material in the literature? Has anyone looked at that, or would you consider it a possibility worth exploring? Yeah. So the roots of the plants possibly can contain therapeutic compounds. You wouldn't see cannabinoids accumulating in the roots. However, there may be other compounds such as flavonoids, and I'm hoping to look at some data that I've taken of some root samples myself, and do drop me a message and I can get you that as soon as I can. I'm writing up my thesis, so it should be in there. But yeah, definitely worth exploring. As Mommy, I had it. Okay, Manav. As we're keen to explore all of the potential value from the plant. Patient, Manav. Why is a heat press not part of the extraction pipeline? Is it not considered extraction when you create rosin? Squeeze the flower under a heat press. So yeah, absolutely. This is one extraction technique, but I would argue is more suited for a kind of trichoresinous cannabinoid rich flower that you're able to cultivate and sample, as opposed to hemp. I'm not saying it's not possible with hemp, and there just may be more better suited processing methods for kind of low cannabinoid content material. UK. Fahid, my other question is, which gender of hemp plants, male or female, produce greater amount of cannabinoids? So it depends. Hemp plants can be monoecious or dioecious. So you can have monoecious, you have the males on individual and females on individual plants, and dioecious you can have on the male and female reproductive systems of both plants. It is understood that female flowers can produce higher amounts of cannabinoids, but that is if they are not pollinated, and fields of hemp typically contain both male and female both male and female plants. And so unless work has been done to respectively remove the male plants, you are going to get pollination, which will impact the amount of cannabinoids. But typically when you are cultivating cannabis for cannabinoid content, you want unpollinated female flowers. Thank you. Ethan, is waste disposal a consideration when choosing a solvent? Yes, absolutely. Yeah, as it should be with but with any method, you should consider the kind of total life cycle and the waste. When this is one of the limitations, I guess, or considerations for solvents. These solvents are, they need to be stored adequately in typically cool, dry places. And yeah, they need to be disposed of appropriately. You can't just put it down a drain. And so these are definitely considerations, especially when you scale up and have industrial kind of solvent extraction methods. Yeah, how you're going to obtain and store and then get rid of these solvents. So yeah, definitely in a consideration. Thank you. And Tyler, has there been any tests looking at the relationship between CBD content and physical characteristics such as size of, I'm presuming it's the stalk, thickness and strength of the industrial hemp plant? Is this relationship proportional? This is, yeah, really interesting hypothesis. So if you consider, yeah, it's a really interesting hypothesis. So I wouldn't say that I've got a study to hand which shows this. Typically you have, it's very important to have a strong stalk to support the plant, which will in turn support the flower leaf production where the cannabinoids accumulate. However, there are hemp cultivars that are better suited for fiber production because they can grow taller with a thicker stalk maybe, but then that will impact their ability to produce cannabinoids. So that's the kind of hypothesis, that with a stronger or thicker or taller stalk, more of the energy is going into creating that biomass and not for cannabinoid production. But this is definitely something that I will look to see in the literature, and I hope you can maybe add to if you do your research. Do let me know. Those are all the questions I have in the Q&A. If there are any more, please throw them at me.
Yeah, it seems like there are no other new questions. Just check the chat. Well, if no more questions are entered, then with that, I would like to thank you, Jamila, for being the speaker of today's session, today's webinar, and all of you for joining us, not just today, but throughout this webinar series. It has been a great pleasure for me to be your host in this 2023 webinar series. And please join us next year for
This has been a production of Cornell University, on the web at cornell.edu.